Hey guys, for those of you that missed class today, maybe Wi-Fi was cutting in and out, figured I'd record what we talked about, and this way you can make sure you're all nicely caught up. So we talked about periodic behavior. So this is a new thing for us, okay? And we call a function is periodic. So a function is periodic if it has a pattern of y values that repeats at regular intervals. So that repeating is kind of a pretty big deal. Okay, that repeating is a really big deal. So a cycle is one pattern. So if I start at this edge here and I go up, down, and then it starts to repeat. Up, down, and then it repeats. Up, down. So see how it keeps repeating. Each one of these repetitions is called one cycle. One cycle. So that's one wavelength is how long it is in the x values, which is also going to be called our period. Okay, so a cycle, a one complete pattern is called a cycle. And it can begin at any point on the graph. The wavelength is however long that is. So the horizontal length of one cycle is called the wavelength. Okay, and the period is the time, so that's the amount of x values that we've got. So here I've got it drawn, and let's see, that goes for 1, 2, 3, 4. So my period is 4. And even when I went to one of my repeating pieces, so in my next cycle, let's count 1, 2, 3, 4. So my period is 4. So each one of these cycles, so there's one cycle, is still equal to 4. Now I didn't have to start there. I could have started somewhere else. So let's pick a different, I haven't done pink yet, have I? So if I started, say, here, and I went up, down, well, there's a cycle. Because then it repeats, up, down, down. There's a cycle. So it doesn't matter where you start, because it's repeating. Okay? So a periodic function is a series of events that are regularly repeated, starting from one point and returning the same point in the same way every time. So here we've got a heart. Okay, hearts, you know, pump blood, right? Ba-boom, ba-boom, ba-boom. So here's our cycle. So if I start at my top, it comes down, over, up, repeat. Down, over, up, repeat. Okay, so each one of these repetitions is one cycle. And let's see, how long is this? It starts from 0 and it ends here. Oh boy, we've got to count our pieces here. 1, 2, 3, 4, 5 grid lines. So each one's 0.2. So 2, 4, 6, 8. So one cycle is going to be 0.8. So the period is going to be for 0.8 seconds because it's seconds on my graph. Same thing underneath. Let's look at our picture. Bump, up, down, repeat. Bump, up, down, repeat. So each one of these cycles, it doesn't matter where you count it from, is still going to be the same length. Now this is a really hard one to read, because it's kind of in the middle. I don't know about that one. So let's pick ones that actually seem to make sense. So if I start a cycle here, and it comes up and down. Oh, it ends beautifully right there. So if I count that as my pattern, because notice how it's going to restart again. Again, it's 0.8 seconds. Okay. Here I have another one. So this one's a nice, simple little pattern. So it goes up, over, down. So how far does it last for? It lasts for 7. So it has a period of 7. And then, well, let's read the graph. So that's what the rest of it's asking. Nice reading of the graph. So f at 4. So that means what's my y value when x is 4? So when x is 4, it comes up, comes over, 1 equals 1. F at 19, sure. Okay, fine, read across. Oh, it doesn't go all the way to 19. Oh dear. Okay, well, we know the period goes for 7. We said our period is 7, right? So let's think. That's going to be the same thing as the function at 19 minus 7. Well, what's 19 minus 7? 12? Can I read 12 on here? Oh, I can. So right there. So they're going to be equal. So that's equal to 0. So f at 19, because it's repeating itself, I can find another point on the graph that's going to have the same y value. We have some more important vocabulary to worry about. Amplitude. So in any periodic function, the amplitude is defined as half the difference between the maximum and minimum values. In other words, it's half the total height. Okay, so on our picture, you kind of have to look for, let's see, do I still have good transparency? Yep. So there's my total height. Total height is 4. So it's half of it. So half of it would just be up from this middle line. Half of it would just be down from that middle line. So my amplitude would be equal to 4 over 2, which is 2. Okay, so our official equation for amplitude, well, you have to take your maximum minus the minimum and divide by 2. So in this case, let's see, my maximum was 1, my minimum was -1, divide by 2. Oh, did I count that right? No, I didn't. Haha, maximum's at 2, bottom's at -2. It gives me 4 over 2, which gives me 2. Oh, I just said that. Oh, look at that. Oh, look at that. I already know what I'm talking about. This is good. Maximum and min value. So the maximum's up at the top here. So I just put the picture on there. Maximum. It's got lots of names. We're going to call it the crest. Okay, we might call it the peak. And at the bottom, so that's my minimum. It's got a few names too. So the trough, that's the bottom. Okay, so minimum, smallest number possible. So the maximum values occur at the top. That's called the crest. Okay, and the minimum values occur at the bottom, which is the trough. Let's also talk about this middle line here. So this middle line that's in between the top and the bottom. So this halfway line down the middle here, halfway, this line that balances the curve on top and bottom, that is our equation of the axis of equilibrium. Sorry, I just kicked my desk a bunch of times there. Okay, so its equation, so my axis is equal to the maximum plus the minimum divided by 2. So in this case, let's see, my maximum is at 2, my minimum is at -2. So in this case, my axis is at 0. So my answer would be y equals 0, because that's the equation of the line down the middle. We're going to move that up and down, so that's going to change. But for this example, it's down the middle. So let's see. Determine the coordinates of the first peak. That should say trough, the period, the amplitude, and the equation of the axis of symmetry. All right. So our peak is a maximum. So it's at my first top. So this is a peak, also known as a maximum. We've got more of them. There's one here, there's one here, there's one here. Okay. Our trough, well, that's at the very bottom. So there's the first one. So that's the trough. Okay, so that's my minimum. And I also see one here, and I see one here. So we've got more than one. So let's put in our answers here. So our coordinates of the first peak. So my maximum peak, that's at y equals 10 centimeters. Our minimum, so the trough, that's at y equals -10 and x equals 1. Oh, we want the coordinates, don't we? So the first one was at x is equal to 0. So 0, 10. So the point would be at 0, 10. And the point for the minimum would be at 1, -10. The period is how long it is before it starts to repeat itself. So from peak to peak, from trough to trough, from maybe this middle line to this middle point, right? Because then it starts repeating itself. So the period goes from 0 to 2. So it's 2 long. The amplitude so we can calculate that. Remember, we said that's max minus min over 2. So that is, what did we say? 10 minus negative 10 over 2. So that's the same thing as 20 over 2, which is 10. Oops. I'm writing and thinking at the same time. So that means from this middle up to the top, there's an amplitude of 10. And from the middle to the bottom, there's an amplitude of 10. And that middle line that I just went through a couple of times, this middle line right here, that balances it, so it's exactly in the middle. So I've got 10 up, 10 down. So that middle line is my axis of equilibrium. So we want the equation. So that's at y equals max plus min over 2. So 10 plus negative 10 over 2, 0 over 2. Oh, so it's just at y equals 0. Right? And it's in the middle. Like I said, we're going to shift it up and down later, but for this one, it's right in the middle. So those are periodic functions. So you're good to go do the task on periodic functions. Okay, that's a Google slide. It's in the classroom. And then we go on in the lesson, and we're going to do 2 very, very, very important sinusoidal functions. Okay, so this is a new parent function right here. So just like you have to know linear, you have to know quadratic, square root, all the rest of it. We have to know sine x. And you can get your table of values, right? Stick in 0, sine is 0. Stick in 90, sine is 1. Stick in 80, sine is 0. Stick in 270, sine is -1. And 360, sine is 0. So to finish figuring out our curve, because it is curvy, we want some middle points. And if I calculator, well, wait, let's just think. Oh, special triangles, we know that's just 1 over root 2. If I calculator that, it's just 0.7. 135 is also 0.7. 225 is minus 0.7. And 315 is minus 0.7. So we're going to create a continuous function using those points. Hang on. It's not scrolling for me. Good. There we go. And I'm going to make this point at 0, 91, 180, 0, 270 minus 1, 360, 0. And then I just have those 0.7s in the middle, in between each one of those, just to help me find my curve. So curvy's there, so that's like an upside down bowl. Then a curvy's here, so that's like my right side up bowl. Now this is a continuous function that goes on forever and ever 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 and ever. So it goes on forever. Which means you can stick in any angle and you're going to get an answer. So x is any real number. There's no restrictions. My y values certainly have restrictions because sine, unless we change it around, just lives between -1 and 1. So it's -1 less than or equal to y less than or equal to 1. My maximum is 1, and that's at x equals 90 degrees. My minimum is -1, and that's at x equals 270 degrees. My amplitude is here. So that's how high the top part is. It's also how high the bottom part is. So it's my total height divided by 2. So my amplitude is 1. The period is how long it lasts for. So one cycle of sine lasts for 360 degrees. So it's like one circle around, one loop around the circle. I have a few x-intercepts and y-intercepts. So let's think about those ones. So I have, let's see, 1, 2, 3 x-intercepts here at 0 degrees, 180 degrees, and 360 degrees. My y-intercept, oh, that's also here because we go through the origin. So that happens, y is equal to 0. 0. No degrees. so there's sine. Very important function. We have one other very important function, and that is cosine. So again, we just have to sub in some values here. So let's think here. So we've got, if I type in my calculator sine, I get an answer of 1. If I type in 90, I get an answer of 0. 180 gives me -1. 270 is back to 0. And 360 is at 1. And again, special triangles, 45 degrees. Well, cosine of 45 degrees, well, that's 1 over root 2, which if you calculator it is 0.7. And then we go to 0. And then we go to negative 0.7. Negative 0.7, and back up to positive 0.7. So those just kind of help to give us our curvy. What you really have to remember are all the 1s and the 0s. So cosine curve starts at 1, 90, 0, 180, -1, 270, 0, and 360, 1. And then in between each one, we've got a 0.7 there to help give us our curvy. So there's my downwards bowl. There's my upwards bowl, and there's my downwards bowl. So y equal cosine. So this again goes forever and ever and ever, starts at the top. So it's the same curve as the cosine curve. It just starts at the top. We can stick in any x value. So x is any real number for my domain. My range, y is any real number, such that, let's see, -1 is my smallest, less than or equal to y, less than or equal to my biggest, which is +1. So there's my maxes, mins, and my mins, and mins. My maximum is at 1, and that happens when x is at 0 degrees and 360 degrees. My minimum is -1, and that happens when x is 180 degrees. My amplitude, just like the sine curve, is 1. So my amplitude, up there, down there, up there. Notice, ooh, I forgot the axis of symmetry. Axis of equilibrium. So the middle line is that y is equal to 0. So there's my axis here. Axis. The period, so the whole thing lasts from 0 until 360. So there's one cycle. We only drew one cycle here. So one cycle, the period lasts for 360 degrees. My x-intercepts, let's see, I've got one at 90 degrees and 270 degrees. My y-intercept happens when y is equal to 1. So there's my cosine curve. So there was my cosine curve. And let's rewind. There was my sine curve. And let's just write down that the y equals 0 is axis of equilibrium. That's such a long word. Okay, so that's that middle line that goes down the middle here. And that's going to be important when we go to translate it up and down. Okay, good so far? So what we did is we made sure we knew what a periodic function was. So something that repeats itself. We've got some very important vocabulary. And then we applied it to two specific periodic functions, which are really the same thing, just one's shifted to the other. Okay, so we've got our sine curve, and we've got our cosine curve. So then we did this really cool Desmos activity, which I would like everybody to make sure that they've done. Okay, oops, that's way too big. And within it, we started playing with the transformations. So let's just do some rough transformations here. So I've got y equals sine x. So we just said it looks like this. 1, 0, -1. So there's 1, there's -1, there's 0. Okay, and then we did some transformations. So the first thing we played with was my a value in front. So a value is our vertical stretch or compression. So in this case, when I talk about my sine curve, it's what's messing around with my amplitude. So if I have something like y equals 4 sine x, well, I'm going to graph my sine curve, and it can still go through 0, but it now has an amplitude of 4. So -4 is my bottom and +4 is my top. If I did this with my cosine curve, let's see, cosine starts at the top, comes down, comes back up. So 0, -1, 0, 0, 1, -1. So if I were to graph, say, y equals 0.5 cos x, well, there's my compression. My amplitude would just be 0.5. 0, 0.5, and I start at up here. There's my y-axis. There's my x-axis. Down, 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 up, up, and curvy. Yeah. So we did stretches and compressions. And then we translated it up and down. So I said y equals sine x plus c. So that plus c out there is my vertical translation. And that's what plays with my axis. So it's actually my axis of equilibrium. So my axis of equilibrium is going to be at y equals c. So when I go to graph it, let's say I have y equals sine x, I don't know, plus 5. So there's my y-axis. There's 5. So that's what I'm going to bounce around. So my curve is going to bounce around it. And then I know my maximum has to be +1. So 5 plus 1, well, that's 6. And bring it down 1. So 5 minus 1. So my minimum is going to be at 4. Same idea if I'm doing a cosine. So let's do y equals cosine x, I don't know, -3. Sure. So there's my y-axis. There's my x-axis. And -3, so I'm going to bounce around my -3. That's my middle line. So -3 plus 1 is -2, so there's my maximum. -3 minus 1 gives me -4, so there's, oops, there's my minimum. And then cosine, so there, 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 and curvy. So we did those transformations. And then our last transformation we looked at was changing the period. So that was y equals sine k of x. So remember our sine curve has a period of 360 degrees. Well, if I make it smaller or bigger, so that k value, that's my horizontal stretch or compression. So if I want a curve that has, say, a period of 200 degrees, I don't know, I'm just making that up. So I want my curve, I want it to end at 200. So in order to turn that into my equation, y equals sine, well, my original was 360, and now I want it to be 200 x. If I want, say, cos x, but I want a period of, I don't know, 800. Let's stretch it out. Let's say that's 800 there. I don't know. Let's see how good I can graph. Up. Let's see. Halfway. Oops. Halfway is there. Halfway is there. So top, middle, bottom, middle, top. And there it is. So half of 80 would be 400, half of 400 would be 200, and 4 plus 2 is 600. So there's my x-axis, and then that's what it would be. And my equation, oops, y equals cosine, it originally was 360, we've now made it 800, x. Cool, eh? So that's what we did.